Hello, everyone. Hopefully, everyone is doing well. So today we are going to start introducing the last topic within energy called power, which some of you may or may not have heard about before. But to start off with, we're going to start with a warm-up question. So in the Zoom chat, I want you to name some items in your home that you've seen with watts on them, W's, things that are measured in watts. So let's see if we can build together a list of things that we've seen, or and seen in Home Depot or at Lowe's or something. What are some things that you've seen that are measured in watts or W's? Maybe it says something like 75 W. So let's see if we can get together a list of some items that we've seen that are measured in watts. And then if you have any ideas, we're going to see if anyone has any idea of what watts mean, or what do you think it's a measurement of. So let's take a few minutes to see if we can piece together some ideas of some things that are measured in watts, and to see if we have any ideas of what watts mean. We got a few good examples so far. Pretty much, you will be surprised at what has wattage in them. Pretty much any sort of electrical appliance or any sort of electrical item has some sort of wattage on them. Technology, perfectly, yeah. Yes, any sort of technology uses wattage. Batteries, perfect. That's a good example of wattage. And if you have any ideas of what watts might mean, what does it mean to have a 75 watt light bulb? What does it mean if we need to, why would a 25 watt light bulb be better than a 75 watt light bulb? Why do if you've ever gone to Home Depot or some other store and you see all the appliances and they have their Energy Star rating, and it's this one is really energy efficient, right? It's also related to wattage. So we have some idea of wattage being a unit of power. We have some sort of idea that it's amount of energy. It's some sort of idea that it's a measurement of energy. So I think we all have some good ideas so far. We got more power, there's more watts. These are some really good ideas. So we're going to explore this topic a little bit more in depth today. What does it mean to have power? What does it mean to use power? Ooh, quantify the rate of energy. That is some big ideas right there that we're going to expand on a little bit today. So we will talk about power later today, and we're going to talk about what watts mean and what power consumption is. For right now, what we're going to do is I'm going to talk about what we're going to be doing today. So here's the plan today. What I'm going to do is I'm going to introduce power. I have a note sheet that you can fill out. It's on Canvas, but I'm also going to put it in the Zoom chat. So you can open that and then fill that out as we're going along. I'm going to try to cover I will cover every single bullet point, every single question on there. So you should be able to, follow along here and just fill it in as we go along. Yeah. So hopefully that'll help. And then when you're done, just submit it on Canvas. It's okay. So that's for our note sheet. And that's on Canvas as well. I just put a link in the Zoom chat, so that'll help you follow along with our introduction today. And when we finish our introduction, so I decided to structure things a little bit differently. You can sort of pick on one of the three things to work on. So I've sort of structured these in terms of 3 levels of difficulty, essentially. You sort of have power practice problems, which are for the easiest. You have your power proficiency, which is sort of, the same level of difficulty as the other proficiency stuff. And then you have your power mastery. So you can pick one to work on. You do not have to start with proficiency. You can start with something easier or harder. It's up to you. And again, if you finish one, you can always work on a harder one. There are a lot of you who are I want an A in the class. Do I need to do the proficiency? Basically, if your singular goal is to get an A in the class, then you can just do the mastery one, that is okay. I would encourage you though to maybe at least take a look at the proficiency so that way you can get some ideas of how to do it. The mastery one is very structured very differently, and I'm not as generous with help on the mastery stuff. So it's up to you what you want to do. But you know, do not have to do the proficiency and the mastery. You can just do the mastery if you want to earn a mastery for the standard. Okay, so that is for that. If you have any questions, you can always let me know. Then I do want to talk about due dates. So in terms of due dates, your singular thing that you have to do is, I have on Canvas, I have a thing called the group work survey. This is just to help me gauge how I want to do groups for next unit. It'll be more group oriented, where it'll be a group project, much more collaborative. So I want to get a gauge and see what people, what are people's, you know, is there anyone in particular you want to work with? Is there any, do you have any particular preferences? So, so complete this by Wednesday, at least before Wednesday. Well, on Wednesday, complete this on Wednesday as your asynchronous assignment. It should not take you more than 5 minutes or so. So if you want participation on Wednesday, I would do this. And I would say it's extremely mandatory. So make sure you do that. And then last but not least, in terms of today, I have a meeting at 3. So I am adjusting my office hours from 1:20 to 3 instead of the usual 2:40 to 3:40. If you come after 3, I may be still able to answer some questions, but I can only like Zoom chat it. I can't really voice or video it. So that's for this today. For those of you just joining late, what we're doing right now is we're going to start introducing the topic of power. I just put it in the Zoom chat. I have a blank note sheet that you can fill out that you can follow along with. And then we will start talking about power. Okay. Okay, so first off, okay, so basically first off, let's talk a little bit about power. So as we know, I think we've sort of, you know, figured out power relates a lot to energy. And more specifically, right, power just sort of relates to how we are using energy. So if you get an electric bill that's too high, if your parents are saying we're using too much power, what that means is that you're just using too much energy too quickly, right? You can use a lot of energy, but if you're using it on the scale of thousands or millions or billions of years, right, you're not really using a lot of power per second. So there's not like, it's not a big demand for it. Power really just relates to how fast you're using energy, right? And so if I were to sort of say what power really means in sort of one sentence, power has energy. We will talk a little bit about the difference between power and potential energy in a second, Leah. That's an excellent question. I will talk a little bit about it in a second. But for now, what we're going to do when we're talking about power, let's first sort of define what power really means. So what power really means, just it's just the rate at which energy is being transferred. Right, so power is literally just us transferring energy, it's us using energy in some way or another, or giving energy. It relates a lot to sort of work in terms of, you know, we're using power, we're using energy, and it's basically just the rate at which it's being transferred. So what does it mean to be the rate? So when we talk about the rate of something, we're basically talking about how quickly we are using something, or how quickly we are gaining something. So with power, when power is the rate at which energy is being transferred, it's really just saying how much energy we can use or gain per second. So if I have a high power rating, if my appliance is using a lot of power, it just means that every second it's using a lot of power. Right. Now, if I have a small power rating, it means that every second I'm not using a lot of energy, I'm using very little energy. So this relates to how much energy we're using per second or gaining per second. So the key thing is power is a rate. It's not energy. Power is not energy. Power is how quickly we're using energy. Now, power is can also be how much we're gaining energy. So, most devices and appliances and stuff, they use energy. So there has to be something that powers them. So if you have a computer, right, when you plug into a charger or something, that charger is providing power to your computer. It's giving energy to your computer. It's not actually taking it away. So power relates to how much energy we can use or gain every second. It's a rate. It's a very important, it's a rate. It's not power. It's not energy. It's a rate. Okay, so now let's talk about, so let's see, what does this mean numerically? Well, if power is how much energy we're using or gaining per second, what we can just say is that power is just the amount of energy I'm using per time. So this right here, so P for number 3. Therefore, we can say that power is equal to your energy divided by time, where E is your energy, T is your time. Power is how much energy we are using. All right, so this is what I'm going to talk about right now is very, very, very important. So if you haven't been paying attention right now, this is the time to pay attention. So notice how in this formula here, we have power, which is P. In physics, a lot of the times you will have a lot of quantities that all have the same letter. This is very frustrating, I know, but unfortunately there are only 26 letters in the alphabet and there are a lot of different kinds of physics quantities. So P is used to measure power. We also sometimes use P to measure potential energy. I try to differentiate it. I usually try to say PE, but I may use P sometimes. And it's very important to know the difference between potential energy and power. What I'm going to say right here is power is not the same thing as potential energy. Very important. They're not the same thing. Make sure you remember this. Power and energy, potential energy are not the same thing. If you want to figure out the difference between the two, power is how much energy we are using. It's a rate. Power relates to time. Potential energy is how much energy you have due to a certain height. Your potential energy itself has nothing to do with using energy. An object can have potential energy just sitting on a shelf, right? But because no energy is being used, that would actually have no power. So the difference is, if you remember the difference, potential energy is due to a location, which is why when we calculate potential energy, we use MGH. And which is why when we use power, we use energy over time. So this is very important. I don't want people getting confused. And they're like, because the one thing I sort of encouraging is, when you look at a problem, you look at the formulas and you try to figure out which one helps you the most. However, now that we are introducing a lot of different similar symbols or similar letters that mean different quantities, now it's important to actually know what these equations actually do. So P is equal to ET, PET. Power is equal to energy over time. This relates to power. You don't calculate potential energy with time, you calculate power with time. Your potential energy, you still use P is equal to mgh, mass times gravity times height. That's what you use for potential energy. The two are very different things. And I don't want people getting confused with how and what the difference is. So yes, I'm repeating this a lot, but this is very important because it's going to be very easy to get confused with this. Okay. So let's talk a little bit about what power is measured in. So because power is measured in energy per time, we actually use a unit called the watts, which some of you may deduce. And 1 watt is one watt is equal to 1 joule per second. Right, so watts relates to how much energy we're using per time. So if I were, and so we use the unit watts, and 1 watt is just 1 joule of energy per second. So if I'm using 1 watt of power, it means that every second I'm using 1 joule of energy. Okay, so what does it mean if I have a 75 watt light bulb? Well, if I have a 75 watt light bulb, it's like a microphone. Anyways, if I have a 75 watt light bulb, right, what this means is that every 1 second, I'm using 75 watts, 75 joules of energy. So a 75 watt light bulb is using 75 joules of energy every 1 second. A 25 watt light bulb would use 25 joules every 1 second. Another important thing is that watts power is measured in terms of seconds. Seconds, not minutes, not hours, not days, seconds. So sometimes you may have to do some conversions. So far, we haven't really done a lot of conversions in this class, just to try to keep things simpler. But it's important to recognize that, again, power relates to time, which is measured in seconds. And if you see something that says minutes, you may have to do some conversions to convert that into seconds. Okay, so before I move on to our practice questions here, does anyone have any questions for me about any of these topics? Is there anything someone wants me to go over again? Something someone missed? Everyone got everything? Question 3. Okay, perfect. Okay, so question 3. Number 3. So number 3 just says that we can just say that power P is equal to E over T. Therefore, we can say that power is equal to energy over time, where E is the energy used and T is the time. Is there anything else that people want me to review before we move on to our practice questions? Okay, so I'm going to go for our first practice question here. Our first practice question here is just basically, how much energy do we need to power a 750 watt refrigerator for 10 seconds? So I have a refrigerator here, 750 watts, and I want to power this for 10 seconds. So how much energy do I need to power this refrigerator? We'll take a couple of minutes and then you can try it out. And then if you're ready to finish, you can just put your answer in the Zoom chat and then we'll see what people can get. Oh, wow. We have some answers already. Okay, extra credit. You finished already. We'll take a couple minutes. You can take your time. Again, how much energy is needed to power a 750 watt refrigerator for 10 seconds? So what we're first going to do is let's just identify what are some of the things we're given. We're given a power rating. We know this because it's measured in watts.
Power is measured in watts. And we're also given a time, which is in seconds. What are we solving for? Well, we're solving for energy, and we know this because it says how much energy. So that's how we know we're solving for energy. What equation do we use? Well, there's only one equation that deals with energy, that deals with power. So every time we want to solve for power, we're only going to use this one equation. P is equal to energy over time. Let's substitute. So power, 750. We don't know what our energy is. We do know our time is 10 seconds. So that we solve for this, we get that our energy is 7,500 joules. Hopefully that was fairly straightforward. If you have any questions, you want to let me know. We got 2 more practice questions in here. So why don't we take a minute to try to figure out problem 7. How much power is needed to, to give a car 100 joules of energy for 20 seconds? I think some of you are already waiting to put that in. Oh my gosh. So take another minute to figure out question 7. How much power is needed to give a car 100 joules of energy for 20 seconds? It's going to be a similar problem, just with some numbers switched around a little bit. Another minute or so, and then we'll start working through this. Okay, so let's first go through our things that are given. We're given an energy, which is 100 joules. We're given a time, which is 20 seconds. We're solving for power here. Equation we're going to use is P is equal to energy over time. Substitute P is equal to 100 over 20. So our power is 5 watts. One more question left. How long does it take for a 100-watt generator to provide 1,000 joules of energy to a phone? This one could be a little bit trickier. How long does it take for a 100-watt generator to provide 1,000 joules of energy to a phone? This one's a little bit trickier. It's important just to remember what numbers are on the top, what numbers are on the bottom, because it can be fairly easy to sort of mix up which one goes on top and which one goes on bottom here. Okay, so I'm going to go through this. What are we given in the problem? We're given a power, which is 100 watts. We're given 1,000 joules of energy. we're solving for time. Our equation here is power is equal to energy over time. Substitute, we're going to substitute 100 for power, 1,000 for energy over time. This part, I think so far up to here is pretty straightforward, just plugging in stuff. The hardest part here, I think, is the algebra here. So the thing is, if you just divide both sides by 1,000 here, your time is going to end up being on the bottom. So what we want to do is we want to bring this time to the left side, and then we want to divide both sides by 100. So if you do that, you'll get that your time is 10 seconds. Hopefully those questions were fairly straightforward, nothing tricky there. Does anyone have any questions for me about what we've done so far? Anything you want me to go over? Okay, so here's what I'm gonna do for the rest of today. We're gonna work on one of the three. You can pick one. You don't have to do all three. You don't have to do. You can just work on one. And if you finish one, you can work on another one. 3 sets, 3 things that you can try. You can try the practice problems, which are the easiest. Proficiency, which is medium, and then the mastery, which is the hardest. I'm gonna start linking them in. They're all on Canvas, but I'm gonna link them in here so you can try. So practice problems.